in the homework looks kind of like this, and perhaps a better view of that problem would be right here. You're asked to graph y equals 9 cosine x, determine the domain and range of the function. So there's a few things that you can get, right off the bat. It has an amplitude of 9, which is not a big surprise. You can find the period because the period is 2 pi divided by the coefficient of our x, and that's just a 1. So we get a couple quick, easy answers for some of this stuff. But then it asks you to graph this using 5 key points per period. And let's talk about that by looking first of all at the unit circle and then thinking about the graphs of sine and cosine. So one of the things that I like to practice and make sure my trig students know is their way around the unit circle with these particular values. So I've got these 4 points. We can kind of think of it as 5 points because 0 and 2 pi are really the same point. They're coterminal angles. But think about the cosine, think about the sine. Let's see if we can't fill in these. So if you're doing this at home for yourself, maybe you want to pause things for a minute and try and fill in the y coordinates for each of these. So I'll give you a few seconds here to pause the video if you'd like. And now let's think about the cosine graph. Well, the cosine function is based on the x coordinates, and the x coordinate here starts at a 1, and then it goes up to 0, and then to -1, and then down to 0 again, and back to 1. And so that's your cosine function. How about your sine function? Well, your sine function doesn't deal with the x coordinates, it deals with the y coordinates. And the y coordinate is 0 is 0. And then the y coordinate at pi over 2 is 1, and then 0, and then -1, and back to 0. Notice that they start and end at the same place. What does that mean in terms of your graph? Well, let's graph each of these. And I'll list some points at 1 and -1. So let's divide up our interval into units of, say, pi and 2 pi. And then I'll do the same thing over here for the graph of the sine function. Divide up our interval in terms of pi and 2 pi, like that. So the graph of the sine, we'll start with the graph of the cosine function. The interesting thing about this is that it starts out at 1. It starts out at 1 and then eventually gets down here to -1 and then back up to +1. So let me kind of snake our way through here like this. Like I said, the important thing to see here is that this graph starts away from 0. It doesn't start right at the origin. Now that's not true with the graph of the sine function. So with the graph of the sine function, you're actually going to start at 0. You're starting at 0, 0. So yeah, I think I should have chosen maybe blue here. Let's do blue. You're going to start at 0, 0, and then it's going to build to a height of 1 when you get to pi over 2. So this is pi over 2. That's going to be 3 pi over 2. So it's going to start out at 0, 0, build to a height of 1, and then back down to 0 again when we get to x equal pi, and then down to a minimum at 3 pi over 2 here, and then back up to 0 again. So there's your graph of the sine function. Now these points are pretty easy to plot. So those are the kind of key points for yourself when you're trying to graph these things. Except it's not always easy to find these points for just any old function. So one of the ways that you can arrange yourself to have these easy points is to kind of solve for them. What do I mean by that? let me show you a different example that uses something that I call the 5-point method. I'm not sure it's just a my thing, but it's basically going to take and figure out what x values to feed into your function so that you end up evaluating your sine or cosine at these easy points. So let me kind of spoil the fun right away. What we're going to do is we're going to try and figure out some points that I can plug in for my x, that when I plug them in and do my 4x plus pi, I'll end up with 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are the points that I want to evaluate my sine function at. So ultimately our goal in this problem is to graph this function over here, y equals 3 sine 4x plus pi plus 1. So that's going to be my y coordinate. We're going to need to figure out the x coordinates in a minute. But let's see the advantage of dealing with these points. If I can figure out the values of x such that 4x plus pi gives me these values, then the sine values are pretty easy. Sine at 0 is going to be 0. Sine at pi is going to be 1. Or excuse me, sine at pi over 2 is going to be 1. Sine at pi is going to be 0. Then negative 1. And then 0 again. So, okay, not so bad. What's going to happen when I go to this next column? What's 3 times this going to give me? What should I put in this next column? Well, what's 3 times 0? 0. 3 times 1 is 3. 0. Negative 3. And 0 again. And the last thing to do is to plug in the y. Or plug in this plus 1 and get the y value. Well, the only thing we have to do is we have to shift this up by 1, right? So 0 plus 1 is 1, 4, 1, negative 2, and 1. So great, those are our y coordinates. The only thing we have to figure out, and this is a little bit of a struggle, is the x coordinates. All right, so how do you find these x coordinates? Well, what I'm going to work on with you is something, like I said, called the 5-point method, and there's a lot of different ways you could do this, but ultimately we want to get the 5 points that map themselves to these. And the way we're going to start out is you're going to take this expression here. Let's see, where is it? Yeah, right here. You're going to take that part of the expression and we're going to stick that in between 0 and 2 pi and then solve an inequality with the argument of this in the middle. So how does that look? It's going to look like this. 0 is less than or equal to 4x plus pi is less than or equal to 2 pi. How would you solve this? You want to get x in the middle by itself. So perhaps one easy thing to do would be to subtract pi from all parts of this inequality. And that'll give me negative pi is less than or equal to 4x is less than or equal to, well, 2 pi minus pi gives me pi. Okay. Then what? Well, to finish solving, I want to divide everything through by 4, right? So that'll end up giving me negative pi over 4 is less than or equal to x is less than or equal to pi over 4. Now I've called this the 5-point method. We just got points 1 and 5. So that's point 1, that's point 5, and we put that up on our little chart. To get point 3, 3 is the average of 1 and 5. And I've got that work up here. If you average point 1 and 5, add them up and divide by 2, you get 0. So that's another point. How about point 2? Well, point 2 is just going to be the average of these two. So if I average 0 and negative pi over 4, so that's 1 and that's 3, I'll end up with 0.2. So you add them up, divide by 2. For convenience, I'll think of that 2 in the denominator as 2 over 1. Multiply by the reciprocal and you get pi over 8. So let's put that in here, pi over 8. And finally, what do you think we're going to have to do to get 0.4? And is?
The average of 0 and pi.
Yeah. So we're going to average 0.3 and 5 to get 0.4. And that's, you know, except for the sign, that work's going to be exactly like 0.2. So let me just squeeze in a pi over 8 here. And for convenience, let me just notice one more thing for us here. If I wanted to, I could write this as negative 2 pi over 8. And this I could write as 2 pi over 8. I know that's not in lowest terms anymore, but why does that help us out? Well, that means to go from this point to this point to this point to this point, we're moving the same space, right? It's pi over 8, pi over 8. That should be a negative here. Pi over 8, pi over 8, pi over 8. So that gives me a way to draw my scale on this axis. So pi over 8, 2 pi over 8, 3 pi over 8, negative pi over 8, negative 2 pi over 8, and I can continue this forever. Now, I don't care about the fact that these aren't lowest terms. By keeping them in something other than lowest terms, it makes it a little bit easier for me because now I can just draw out as many of these as I need. Of all this, we need your x point here and your y coordinate here. So let's start out with negative 2 pi over 8 and 1. So negative 2 pi over 8 and 1, that point's going to be right here. And then what? Negative pi over 8 and 4. So then I'll go up here. At 0, I'm back down to 1. Okay, so I'll go there. At pi over 8, I'm down at negative 2. So there. And then at 2 pi over 8, I'm back up to 1. And so that's one period of your graph. You can play connect the dots like that. Now, if I ask a question on the exam like this, I'm probably going to ask you to do 2 periods. Now, does 2 periods mean we got to do a lot more work? No. Remember, this is periodic. The graph repeats itself. So 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8. How can we extend this? Well, follow the pattern. So the next point to the right of this, because that's where we are in this graph, the next point to the right has what y coordinate? To the right of this, if I move to the next point, what's the y coordinate?
Y coordinate positive 1.
We're already at 1.
Right.
If I move to the right, then I'm up here, it's positive 4. So the next point here I'll graph is up at positive 4. And then the next point over from that has a y coordinate at where?
Positive 1.
Positive 1. And we'll keep going. Where's the next y coordinate after this?
Negative 2.
Negative 2, down here, and then back to 1. So if we graph 4 more points, and play connect the dots, now we've got a second period, right? So here's the first period, that distance there. Here's the second period, that distance here. So first, second. Now, we didn't actually spend time finding it, but we could have. Remember, how do you find the period of the graph? Well, the period equals 2 pi over b when you're talking about a sine of bx plus c. So in our particular case, that's going to be 2 pi divided by 4 simplifies to pi over 2. And if you count, say, here to here, 6 pi over 8 minus 2 pi over 8, 6 pi over 8 minus 2 pi over 8 gives me 4 pi over 8. But 4 pi over 8 in lowest terms is pi over 2. So nice. So this kind of confirms graphically what we could have calculated at the start of this problem. So that's what I call the 5-point method. The toughest part is coming up with these points. When I used to give these problems more regularly, I would give 4 points just for getting this. Another 2 points for getting here, and then a couple points for drawing the graph correctly. But the hard part, there's no doubt about it, is getting these numbers. So, a workaround on that is if you wanted to, you could do this in degrees. You're just going to have to convert it back to radians. So, yeah. Now, as far as this one is concerned, the one that we just looked at with a cosine of x, because there's no x, there's nothing in front of the x, and I'm not shifting it left or right or anything like that. You would just use these 5 points to draw your graph. So what would that look like? Let's see here. Let me just do it this way. Let's do a new graph. Y equals 9 cosine of x. And the 9 stretches out your graph so that you have a height of 9 and a bottom here at -9. So, okay, not a big surprise there. And if you need to draw 2 periods of that graph, that's fine as well. We can do that. Let's label these, give it a step of pi over 2 maybe. And zoom in. There you go, pi over 2. Or we start at 0, and then 2 pi later, you've got 1 period of your graph, right? And then another 2 pi later, so out at 4 pi, there's another period of your graph. So if you go out to 4 pi, you got 2 periods of your graph. You feeling better about this one?
Yeah, the table makes it
Okay.
more easier to understand.
Yeah, I would recommend that you get comfortable with these values, this table. Not that it was part of this video, but you should also know where cosine and sine are 0. Cosine is 0 when you have multiples, odd multiples of pi over 2. Sine is 0 at multiples of pi. So those are a couple of good things to know that you can get out of knowing this graph and this correspondence real well. And notice what we did with the graph of the cosine here. We just stretched it by a factor of 9. That's how you went from a graph like this to the graph that we just looked at right here. The only difference is that you're going up to 9 and down to -9 as opposed to 1 and -1 as we did before. So the range would be -9 to 9 inclusive.
Because it stretches vertically.
Yeah, that's exactly, that's a good way to put it. X. So when I change this value of b, it's just going to stretch the graph. And if I make that value negative, it's going to reflect it across the x-axis, but it's still going to stretch the graph. That value of B, be it positive or negative, the absolute value of B is your amplitude, which is the distance between the center line and either a peak or a valley. All right, good deal.